Welcome to Okonko Academy. In this tutorial, we will be talking about Thevenin's theorem, where we find the current through a particular resistor with the help of this theorem. If you are new to this channel, I'll urge that you please click on the subscribe button to subscribe to this channel and put us on post notification so that when we post new content, you'll be notified for you to watch. Now back to today's tutorial. Suppose we are asked to find the current through a 10 ohm resistor. What we do with the Thevenin's theorem is that we first find the Thevenin's voltage and also the Thevenin's resistance. Now, the Thevenin's theorem states that any linear circuit connected between two terminals can be replaced by a Thevenin's voltage in series with the Thevenin's resistance. Now, the basic concept behind this Thevenin's theorem is that whenever you are given a question like that, you have to first find the Thevenin's voltage, then you find the Thevenin's resistance, then you draw a new circuit having the Thevenin's voltage in series with the Thevenin's resistance, which will also be in series with the resistor that you want to find the current that will be moving through. Now, let's move on to the question. So, for this question, what we have to do first is that we would remove the 10 ohm resistor and replace it by an open voltage source. So we redraw this circuit to be in this form. We redraw this circuit to be in this form. Now, for the 10 ohm part, we will replace it by an open circuit. An open circuit, and that circuit will have a voltage which is equal to the Thevenin's voltage. Then you write the rest of the voltage of the voltage sources that we have in the question. Now, suppose a current I passes through the circuit. Now, under normal circumstances, when a current reaches a node, it splits into two or more depending on the connection of the wires at the node. But we should also take note that current will always move in the less resistive part, and since an open circuit has an infinite resistance, the current will not split at the node to move through this part and this part. It will just move through the 15 ohm resistor, so this current will not split. It will not split. It will just move through the 15 ohm resistor because of the open circuit which has an infinite resistance. So, using the Kirchhoff's voltage law, we take a loop in this direction. Now, for the Kirchhoff voltage law, we said that it is equal to the summation of all voltage source, or the algebraic sum of all voltage source should be equal to the voltage drop across all the resistor in the path that we are taking. So, since the current will move in this direction from the 5 ohm to the 15 ohm, back to the negative terminal, then to the positive terminal, it will end at the positive terminal, and so the voltage will be positive 47, which will be equal to the voltage drop across the 5 ohm resistor, which will be I multiplying 5. So I multiplying 5 plus I multiplying 15, the voltage drop across the 15 ohm resistor. So that is going to give us our I. That is going to give us our I to be equal to, that is going to give us our I to be equal to 2.35. So our I will be equal to 2.35 ampere. Now we are not done. The question is, we said for us to use the Thevenin's theorem, we should find the Thevenin's voltage and the Thevenin's resistance. Now this current that we found is going to help us find the Thevenin's voltage. Now for the Thevenin's voltage, we choose this direction to be positive. You can choose any direction, but you should make sure that your sign convention is really good. I will put the link to the Kirchhoff's voltage law for you to watch so that you get to understand how we get our sign conventions. Now let's take our loop to be in this direction. So if our loop is in this direction, we are going to get our current, we are going to get our voltage to be, since for this voltage the current moves from here to the negative then to the positive, it is going to be positive 32 plus, and since the Thevenin's voltage that we've chosen follows that same direction, this same direction, it will also be positive. So positive Thevenin's voltage, which will be equal to the voltage drop across the 15 ohm resistor. Now we are just finding the Kirchhoff's voltage law across this small loop. So in this case it would have been B, C, J, F, B. So we have to find the voltage drop across the 15 ohm. So I times 15. Now since I is equal to 2.35, we replace it by that multiplied by 15. So we get our Kirchhoff's voltage to be, 3.25. Now our Thevenin's voltage to be 3.25 volts. Now we've gotten our Thevenin's voltage. So the next thing to find is our Thevenin's resistance. And as I said, for you to find the Thevenin's resistance, you should take off all the voltage sources in the circuit. We take off all the voltage sources in the circuit, and for the resistor 10 ohm, we close circuit it. So our new diagram for the Kirchhoff's for the Thevenin's resistance will be equal to this. So our new diagram for the Thevenin's resistance will be this. Our new diagram for the Thevenin's resistance will be this. So in this case, this will be the Thevenin's resistance. So in this case, the 5 ohm resistor and the 15 ohm resistor are parallel, since we can traverse through this small loop without passing through any voltage source. So we can traverse through this loop without passing through any voltage source. So we get the Thevenin's resistance to be equal to the 5 ohm resistor in parallel with the 15 ohm resistor. Then we get 15 times 5 divided by 15 plus 5. Then we get our answer to be 3.75 ohm. Now we've gotten our Thevenin's resistance and the Thevenin's voltage. So as the law states that we can replace this linear circuit with a Thevenin's voltage in series with a Thevenin's resistance. So we redraw it to get a Thevenin circuit. So for the Thevenin circuit, we can draw it as this. So the Thevenin circuit, you can draw it as this. Now this portion will be the resistance that we are looking for. In this case, is the 10 ohm resistance, and the Thevenin's resistance and the Thevenin's voltage will be at this portion. Now since this resistor and this resistor are in series, they are in series because when we traverse this circuit, we will pass through a voltage source, and so we consider the Thevenin's resistor and this resistor as in series, and so the total resistance for these two is going to be the Thevenin's resistance plus the 10 ohm, and that will be equal to 3.75 plus 10, which gives 13.75 as ohms as the Thevenin's resistance. So if you want to find the current through the 10 ohm, it will be equal to the Thevenin's voltage. The Thevenin's voltage will be equal to the current through the 10 ohm multiplied by the total resistance. So this will be the total resistance multiplied by the total resistance. So we get the current through the 10 ohm to be equal to the Thevenin's voltage divided by the total resistance that we found. So the Thevenin's voltage as we got was 3.25. So 3.25 divided by the total resistance, which is 13.75, which gives us our current to be equal to 0.236. So our current is equal to 0.236 ampere. Thank you for watching this video to the end. Do well to like, comment and subscribe, and make sure you put us on post notification so that you get to be told when we upload relevant concepts. Thank you for watching Okonkwo Academy. See you again.